after after doing my IIT, I came here to pursue my graduate studies. For a few years, I shifted away from engineering and was doing doctoral studies in quantum field theories and gravity. Then came back to engineering and then worked at for short stints at NCSA, NASA. Then joined a company called Siebel, which got acquired by Oracle. So I was with Siebel and Oracle for many years. Then got into startup mode. Was the chief architect, and way back in 2011, started a big data machine learning group, research program. That work led it to be acquired, the startup to be acquired by a much bigger learning platform. And I spent about 12 years in that, leading that research program. After that, I started Support Vectors, which is which is again a pure AI-centered company. We have 3 legs in the AI lab. We provide, obviously, we solve problems, practical problems, implement things. We give guidance to companies. We do, for example, due diligence for acquisitions and mergers, or companies that are launching out on AI. We provide them with a lot of guidance in their AI journey. And at the same time, we also give corporate training in AI, especially in some of the things that are very fast moving and in which, frankly, there are no textbooks, things like the large language models and multimodal learning and so on and so forth. So our internal work here at Support Vectors includes a lot of multimodal learning. We do a lot of, for example, image to text, text to image, and healthcare related aspects. So there are many areas we work on. We look for fraud detection using large language models. We do knowledge extraction from text, and we do speech synthesis. And so there's a whole range of activities that we do with large language models. And sometimes we have to do it at fairly big enterprise scales. So that's my background.
Thank you, Asif. That's, as you have heard, that's a vast Silicon Valley kind of hat that, you could imagine. So let's start with a couple of sentences. So I'm a Twitter freak. I'm gonna come out and say that I basically stay on Twitter for hours pretty much every day, read a lot of stuff. One of the things that kind of amazed me this morning, I was reading about this whole OpenAI developer, thing that they kicked off. Believe it or not, I'm sure you're probably aware of this. They've named GPT-5 as Gobi. That was so funny, and I couldn't even stop laughing at it, looking at the name. So there is always a new model that coming up, to your point, Asif, from the overall AI evolution that's going on, Gobi, Guac, Grok that Elon Musk just introduced, and it's been pumping quite a much, and there's a lot of good response for that based on the real-time capability that Grok is kind of demonstrating. So can you, I know you've been doing a lot of research, which I know for firsthand. Can you take this group through the commercial models, that large language models that currently do exist, and the strength and weaknesses at a brief level of those, and then we'll dive into the open source models equivalent to those, and then we'll do the comparison. So if you don't mind taking us through that commercial models that do exist in the current market.
See, when it comes to commercial models, there are 2 ways of interpreting it. Models that companies have built, and they are keeping it to themselves. They are not revealing, or they are not opening it out to the public. So there is a huge number of models which I would put in that class. So for example, Google's some of the models, Gemini work currently is not yet released. Baidu is doing a lot of work, but quite a bit of the work is not released. What does happen, though, is every once in a while, these giants, these huge AI related companies, most of these are obviously Facebook, OpenAI, I mean Meta, OpenAI, Google. These are the usual suspects in Microsoft. And then in Tencent and Baidu and so forth, they tend to release APIs to their system. For example, the poster child of all of this started out with ChatGPT. When ChatGPT came, and even before that, when GPT-3 came, we saw that OpenAI was not keen on releasing it to the public, but after some time they did. But 3.5 came out, GPT 3.5 and GPT Turbo, and they were only accessible through APIs. And the reason given were varied. In the beginning, it was said it's too big, it's too dangerous, and so on and so forth. And finally, there was an API, Open AI API, through which it was accessible. And it became sort of the most well-known commercial model. If you are in the Google Cloud, then of course you're familiar with um, a lot of the models that Google exposes under its umbrella of Vertex AI. In particular, when you're talking about healthcare, they have a significant lead. The models that they have trained in AI, I think, are better in the healthcare space, are better than anyone else's model as of this moment in the commercial space. So, so those are, for example, Bard, which is a competitor to Chat GPT, rests upon their internal models. Then there is Cloud, which is again a conversational agent, conversational thing, and it is backed by Anthropic and their commercial models. Then there is Cohere. Cohere, which started out with its roots in semantic search, now is trying to catch up and compete with the rest of it. So these are the large commercial models in the sense that they're generative models. Then there are models that do more limited purpose. Like, for example, if you were to go to look at Pinecone and so forth, and a lot of these, they are more focused on retrieval, data retrieval, or semantic search, and they do very good vector embeddings and so forth. So there is a fairly rich collection of commercial models that are accessible that you could, obviously paying a certain licensing fee, you could use them and integrate into your systems.
Thank you. Are these models available as a service for the enterprises?
Yes, they all are available through an API. And OpenAI's API, for example, is perhaps the most popular because it's a general purpose model. Now, by now it's beginning to show some limitations. So, for example, Cloud and the Anthropic model, it does not have a token limit. You can give it a text with instructions and prompts that can span close to 100,000 tokens. That's practically, as far as practical use cases are concerned, that's unlimited length of instructions and tokens. And it is also available as an API. You could use it. Likewise, Bard, I mean, Vertex AI has quite a bit of their models available as an API, assuming you subscribe to the GCP platform. So there are a lot of these, and now Amazon is coming out with its own services based on some of these models and so forth. So most of these commercial models are available as an API that you could use. So they are all residing on their servers, their clouds, and you use them or you integrate with them using the API.
So how do they measure the profitability in their models? Any thoughts on that?
I would, at this moment, it's basically a cold war. It's an arms race.
I see.
So while you could say that if I set up a cluster of so many GPUs, so many thousand GPUs, and we do know that, for example, OpenAI's and just ChatGPT takes a massive amount of, I believe, 16,000 or some a very huge number of servers that we hear about, GPU-enabled servers that form the backbone of these services. if you ask this question, are they profitable? The answer could be, it's hard to tell. For example, OpenAI just came out with a statement that they're close to 100 million users, daily users of their OpenAI and ChatGPT systems. People are paying $20 a month to use ChatGPT. People are paying a licensing fee to use and integrate with the OpenAI's APIs. Are they profitable? I don't I don't know, but if I were to venture a guess, I don't think so. OpenAI just announced that they are going to do what I heard is a 10x reduction in price of their service. That makes it very, very inexpensive to use it. In contrast, if you were to host your own models, it would be more expensive. Now, this is by design because all these commercial models at this moment, besides the fact that they do compete with each other, but at this moment, the biggest threat that they face, and that showed up in one of the documents that leaked out of Google, the biggest threat they face is from the open source community. And at this moment, the tendency seems to be to prove that instead of hosting your own model using open source, your own environment, why don't you just use our services? Our services are much cheaper than you requisitioning a lot of hardware in GCP or in the cloud and putting any open source model and fine tuning it. That seems to be the message they are driving for at this moment, which explains why they are so inexpensive. It cannot be, it's not an economically viable situation. They can't go on long term like this.
Yeah. Yeah. I mean, to piggyback on that particular point, so if I were to, the audience that we have here are more of CXO folks, not necessarily technology. So if I were to kind of look at a service that probably I could work with Google or Microsoft or any one of them, build a company for that service. So it's more is a mimicking of how the cloud service typically is provided to the enterprise, and there is nothing net new here other than if you are going with GCP, you get to use the Google models, and is that their typical approach here, Asif?
Yes, that's the way the cloud providers and this big AI, and OpenAI is the exception, but OpenAI is deeply integrated now with Microsoft's Azure cloud. But the way the commercial companies have always said is that everything is a service, cloud service. Just use it and integrate with it. And so the AI itself has been reformulated as extensions of cloud services. If you're used to using database as a service in the cloud or anything as a service in the cloud, this is also essentially AI software as a service, in
Got it.
effect.
Okay. We'll on this topic, Sushant has a question, so go ahead, unmute yourself and ask. Go ahead, Sushant.
I think first one is a comment and have a question after. Madhu, you were asking about the profitability, right? I don't think all these companies are actually thinking of profits right now, because in one of the interviews with Satya Nadella, Microsoft CEO, he was like, we are investing a lot on generative AI. And then he said, it's, yeah, we do invest a lot in R&D. We have been investing. But with generative AI, it is really a lot, right? So I don't think they're actually starting to think of how to make money yet, because like what Asif mentioned, it's a Cold War arms race kind of thing, right? So yeah, that is just a comment. But so Asif, a question I have is, so when so many people are providing different services of their own generative AI models, right? So, and say, for example, you hosted your application in one cloud. Is there a way to actually leverage the service from a different provider?
Oh, yeah, that is happening all the time. For example, a lot of the enterprises that are sitting in GCP, I know in particular, they are integrating with OpenAI And a lot of so-called generative AI companies that are happening. And because I do a lot of due diligence and acquisition mergers and look under the cover, quite often they are value add or very specialized applications built on top of OpenAI or Bard or things like that. But OpenAI in particular, because it was the first entrant into this field in November, they practically shook the world coming out with their ChatGPT. So a lot of them, irrespective of which cloud platform they are on, they are integrating with OpenAI. Likewise, there are many people who are sitting, for example, if you're doing healthcare, it doesn't matter whether you're in Amazon or where you are, you tend to integrate with GCP's models, which are actually pretty superior. So for example, if you give it a patient's case history and a consult transcript and ask, what are the differential diagnoses you can come up with? Clearly, you can see that the Vertex AI's offerings, the Google's offerings, tend to do significantly better than others. So multi-cloud strategy or multi-cloud traffic going back and forth at this particular moment is very, very common.
Uh, um, so my question is more towards like if I have my own data, right? I mean, I
Yeah.
want to, like a hospital system or any Pepsi or Coca-Cola kind of companies or whoever it is, I want to train my data with this LLM model, right? So and that is, and I do my due diligence and I understand, okay, I like Google's model better, but I have my cloud hosted in Amazon, right? So do you pump your data into Google, train it there, do the and get the inference from there and route it via Amazon or?
Yes. So there are two aspects to it. Do you need to? So the way we speak in AI, especially in the context of large language models, are three terms that you hear. Foundational pre-trained models. This is what these guys will give you. If you use those and it serves your purpose, then all you're doing is sending your data for inference and inferences come back. You give your data as input, inferences come back. So that crossing cloud boundaries is common. You just have to be careful because all of these cloud providers, they charge you for data egress. Whenever data leaves their system, they charge you quite a bit of money, right? So you have to watch out for that cost. Then the other thing is if you need to fine tune the models, in other words, from the base models, you need to use their models and create a fine tuned version, let's say with the OpenAI or with Google and so forth. Now you're talking of a significantly higher volume of data that will go to pre-train and that fine tuning the model. And yes, it is something to worry about. How much data are you shipping? But generally, fine tuning is a one-time cost, so you don't worry too much about it. Then comes the last phase. Generally, in the cloud, if you say, I'm going to requisition a few hundred GPUs and then train a model from scratch, pre-train a model from first principles, then you are getting into a very expensive multi-million-dollar play because now you're talking about a lot of hardware, a lot of data, and a lot of time that goes into it. Even the data with which you pre-train these foundational models on your own for your own purposes, uh, uh, data comes very noisy. It has a lot of toxic things and noise and errors in it. So you'll end up using that. The statistics at this moment is just 1 to 3% of the data will survive and go into the model because your pre-processing steps will eliminate it. So with that level of data transport and model training and time consumption, it becomes a very, very expensive play, which is why companies that do end up training their own models from scratch make a big splash in the media telling you and telling the whole world that they have trained one more foundational model of their own. It is not very common to do so. And in fact, for most commercial purposes, I would strongly discourage people from doing it unless there is a proven need for it.
Yeah, that kind of makes sense. So we'll just cover the open source models similar to the commercial models. So as if you could, based on your research, what are the evolving open source models competing with these big players at this point, and the kind of strengths that you are seeing from your research perspective?
See, open source came upon the scene, I would say, from March onwards. Still, from November till March, April, if you look at the academic and the open source community, there was a sense of pretty grave concern. The term being used was industrial capture, that a few big companies only have access to all the GPUs and all the hardware resources to train these large models. And they were not willing to share it anymore, right? They were not being open. For example, even today, we don't know how GPT-4 is implemented. Through rumors, we do know that it is a mixture of GPT 3.5 turbo models, but these are all at the level of rumors. There's no definitive statement. More or less, we have figured it out, but through a lot of alternative means. GPT-5 is about to come out. Again, these people are holding on to it. All of these commercial people will assure you that the only way you can train the model is with thousands of GPUs. The only way you can run inferences is again with thousands of GPUs. The open source community's foundational approach is, what if this is not true? What if we can get equivalent performance using much less hardware? And if you look at the open source community, they have taken an approach. They have done groundbreaking work in creating parameter efficient fine-tuning of the models. They create, for example, the concept of LoRa, low-rank adaptation, is a most remarkable idea. It takes a large language model, a pre-trained model, and it says we can fine-tune it for any commercial purpose or any real-world purpose, but we can train it on very relatively modest hardware. For example, if you have a single server with 4 GPUs or 8 GPUs, a typical A100 or H100 or 4 GPUs sitting there, and that will cost you, let's say, anywhere from, depending upon what hardware you're putting, whether you're putting A6000s or H100s, anywhere from $50,000 to $300,000. One server would cost you. You can actually train for your business, for your real world situation, completely fine tune a foundational model for its purpose and get remarkably good results. That is for training. When it comes to inference, you need even less hardware. You can run a pretty high. For example, here at Support Vectors, we have a 4 GPU server, and we index the entire Wikipedia. We created a vectorization of the entire Wikipedia, every single article, every piece, for a semantic search engine. And the entire time that it took to create vector embeddings of it was 8 minutes. This was unheard of. If today you use OpenAI's, for example, the ADA 002 model, the state-of-the-art embedder, it will take Wikipedia, if you do embedding of that, it will take you hours, if not days. And so open source community has actually moved ahead, and they have found ways to do things better with less hardware. And that has been their mantra. And it is very liberating. Otherwise, you will have industrial capture. All we will be doing is, integrating with the APIs of commercial companies, and they are not going to keep the prices low because they are losing money at this moment. Soon they'll jack up the price. On the other hand, with the open source coming, that whole sort of an industrial capture was broken open. Today, the situation is this. Especially if your data is very confidential, you don't want the data to be floating around, no matter how much the commercial companies assure you that they will keep your data safe, that they won't do this, that they won't do that. And I'm sure they mean it. There is always the fact that they can be hacked and your data can be stolen. It happens all the time. After all, Equifax got broken up and all our private financial information is out there, right, in the dark web. And so the last thing you want is your company's confidential proprietary data to be sitting there in the dark web just because one of these providers got broken into. The big safeguard you have is you can use an open source model as a foundation, fine tune it on your data, keep your data in-house, have your own model that only you guys have access to, and work with that. And so open source should be a very, very serious consideration if you do have talented engineers who know what they're doing.
Great point.
I
We do have a couple of hands, so let's go with Ajit. Go
Yeah.
ahead.
So Asif, my question is actually I'm working at GSK. I'm one of the Gen AI lead there,
Mhm.
and we are looking at various use case patterns, right? In terms of the patterns for mainly specific the content development side, document summarizations, question answering, document generations, all those different ways of looking, and we followed a different architectural pattern there. So prompt engineering is one. Then fine tuning model, what you just explained, with that is something we have not achieved yet, but we are following RAG, retrieval augmented
RAGs, yes.
generation, right? And we have knowledge base graph and few DVs which are integrated with that process. And we found it more cost effective as of now, looking to the volume of the data, right? And that's something we are integrated with the vector DVs, doing semantic search, getting the right prompts, minimal form prompts to retrieve the information. So I would like to know, like, two questions I have on that, right? One is, I found it's very cost effective before we go to the fine tune model. But I would like to know from the productions ready point of view, how you see in difference in these two approaches. And second thing is support vector. I'm still trying to understand that the product. Is it a kind of a vector DB similar to Azure Cognitive Search or Pinecone or whatever there in the market? How it is bringing their solutions there, right? These are the two things what I would like to know.
Okay, so your first question is to talk about your approach. Actually, Ajay, I have some of your technical people. They participate in the AI, the AI training that we give. In fact, in the current cohort of large language model bootcamp that's running, we have participants from Glaxo, from your technical team. So
really?
I am quite familiar with the. Let me not name those people, but I'm familiar with. I'm quite familiar with what you guys are doing because they keep taking my advice over time. So
and Asif, we have multiple verticals. We have
yes.
GP&T, R&D. I'm part of the R&D, and
Okay, excellent.
so there are multiple communications happening. So if one specific vertical reached out to you for the training, so definitely if R&D side, if something has not done yet, that's something we can discuss eventually.
No, I would love to. Actually, the experience of these people has been very positive. They say they find everything here very useful. They're coming at the individual level and trying to get it expense reimbursed, educational reimbursement for Glaxo. That's the situation they are in. They're not, but I would love to do a corporate training deal. But let me answer your questions first, though.
Sure.
See, Ajay, you hit upon the mark. First of all, prompt engineering. Now, if you look at, and when you talk about RAG, in this bootcamp, actually, we covered half of the bootcamp was almost first third was on RAG, or first fourth was on RAG. See, if you can answer your question with just proper instruction creation and prompt engineering, nothing like that, because the development cost is relatively modest and you're using a large language model for it. Just this week, a research came out which who published this research? I would like to say DeepMind just came out with this research this week, I think. What it says is that these things are not, they go back into their memory, so in the parametric memory of the large language model, and from there, if they can extract the answer, then with instruction, with prompting, you can get those answers, right? And it's very good at that. Now, the fundamental problem that you suffer is that of hallucination. And the way to, so what RAG solves are two fundamental problems. One is it mitigates hallucination because you say, substantiate your answer based on the information retrieved from the semantic search. right? From the information retrieval from a knowledge base. And especially for a domain like medical or for pharmaceutical like Glaxo, you have a pretty large knowledge base. And so when you do a semantic search and you get that and you say, this is part of your instructions, here are the documents or here are the results. And now here is the question that is being asked. And when you respond, then you are benefiting from two things, what people call the parametric memory of the LLM itself and the non-parametric, the knowledge base that is there. Beauty of the knowledge base is it can be far more recent. The knowledge base keeps evolving, but your model, the OpenAI model or whatever it is, has been trained, last dated in 2021. So you get the best of both the worlds. But more than that, you also mitigate hallucination. So it is definitely the right approach, especially for large enterprises, which are very knowledge intensive, is doing it. Second thing is you talked about knowledge graphs. Absolutely the right thing to do. The trouble with knowledge graphs has been, Ajit, as you know, that creating a knowledge graph, creating an ontology or a semantic web is a very painstaking process. If you look at the world, Google has a very good knowledge graph. Wikipedia Foundation has a knowledge graph. But in the open world, there are not that many knowledge graphs actually available. But companies, especially pharmaceutical and medical companies, because they have a narrow domain, it makes a tremendous value to create knowledge graphs. It's expensive. Recently, and I'm sure you must be doing that, one of the things large language models have become good at is they can extract the triplets. For example, Delhi is the capital of India, kind of thing, those triplet relationships out of which knowledge graphs are built. And so that accelerates the creation of knowledge graph and by orders of magnitude reduces the human cost, the very tedious process of creating knowledge graph. The third thing to remember is that, see, when we talk about large language models, behind them are transformers. And one of the things that has happened is, and this is a thing that not many people appreciate, is the tremendous strides that graph neural networks have made. When you hybridize graph neural networks, and especially attention-based graph neural networks, with knowledge graphs, you practically have a revolution. And when you put all of that together with RAG and so forth, you get excellent results. Now, I'll come back to your old question, prompt engineering versus fine-tuning versus full training of the model. As I said, prompt engineering is should be your first approach. And you always do something for a business purpose. If your business purpose is served, you stop there. If it is not served, then you talk about fine-tuning a model. Fine-tuning is still within the realms of what you should do if you get improvement on it. And of course, as a matter of last resort, at some point, because for example, in Glaxo, it does make sense that for some very specific things, for example, I'm sure you're using AlphaFold, but in some particular case, some particular use case, you may decide that we do need to train a model practically from scratch for this, because no such model exists either in the commercial or the open source space. So that would be the rare exception. I don't know if that answers your question.
No, that helps. Thanks for it. And one last question I have. We started exploring agent-driven architecture. When I say agent-driven, is more specific to our domain-specific agents, not like tech agents. And what we are trying to define is different patterns of the architectures for each of the agents. And I would like to know, because it's a new concept and we're still exploring to define it. What are your thoughts on this? How you think?
Good question. So first of all, it's a great direction to pursue. The coming year that you will see an explosion of work done with agents. So what agents do is they facilitate. So imagine you have delegates, you have experts, or a mixture of experts. So you can take an approach that there is an agent who is very good at each task, but the purpose of agent is to dynamically infer, to take a task, break it up into smaller tasks, decide who to delegate to, and therefore use that. In fact, to the best of everything that we know, that is exactly how ChatGPT has been implemented. Right? It is just a magic of agents. And if you look at, for example, LangChain, its main value comes from the dynamic chains that are created by the agent breaking a problem down into pieces. So agent is certainly the right approach to do. Now, a bit of a caveat. See, if you take a book on artificial intelligence, and for example, if you were to take this book, which is now in its 4th edition, and is the great classic, like, you must be recognizing this book, right? It is the great textbook. It has been for many, many years, for decades in artificial intelligence. Even today, when you open this textbook and you go beyond the first introductory chapter, the first meaningful chapter starts with agents. So AI, real AI, has always been very agent-centered, or believe that agents are the way to go to get to real AI. And that is coming to fruition in this, as we move forward, it will more and more be coming to fruition.
Okay, cool. Yeah, thank you.
Thank you. Thanks, Asif. Bless you. We'll go to Partha next. Go ahead, Partha.
Hey, good evening, everyone. I think you answered some of my questions in your previous answer. So let's say for somebody who has a lot of sensitive data on premise, who cannot afford to send anything outside. I mean, there are so many companies like that, right? So and so in that scenario where you cannot really invoke an LLM on the cloud or a cloud service, for example, like you said, using an open source LLM on-prem to start training it from scratch, is that the only option? I mean, and also I think I saw the question from Sushant. I have the same question too, because I challenged my engineering group some time ago. Hey, you know what, guys, go figure out like Facebook Llama or some other open source model. Just try to deploy it on-prem where nothing can leave outside, right? It has to be so secure that you cannot do anything that can go out. So have you come across those scenarios, and what exactly people are doing in those kind of scenarios, and what models are they using?
See, Partha, a very good question. So I'll unpack it into parts. First of all, as I said, your progression should be prompts, RAG, this retrieval augmented generation through internal LLMs and on-premise LLMs. These should be your methods of first use. Your method of last resort should be using a commercial LLM like OpenAI. I'll explain to you why. First of all, open source has made a lot of stride. By the way, if you're using Meta's Llama 2, then consider Mistral. And now Zephyr has come in. They're coming in quick succession. Mistral, by the way, is very, very good. It's a significant advancement. And it is more or less a drop-in replacement. So many companies I am seeing going to full production using just internal prompt engineering RAG. I mean, now we have something called active RAG, Flare, and using the open source models, widespread adoption. What is now, having said that, there are also a lot of companies that are saying, why bother? OpenAI, excuse me, is so inexpensive. Cloud is so inexpensive, or Bard is so inexpensive. Let's go integrate with them. The problem is they are artificially inexpensive. Your architecture, once your code base is written, a typical code base has a lifetime of 10 years. What it will mean is that once you create an architecture around a third-party software, the moment the cost increases, you will have internal debates now that is it more expensive to re-architect, or is it more, or should we just keep paying the price, right? Those debates will start happening sooner than you think in companies. It's just like Amazon, right? Amazon used to be way cheaper than everything, used to be far less expensive than in other places or in local shops. Now the tables are turned. At this moment, the federal government is apparently suing Amazon because it seems to have made $1 billion using a secret algorithm to price optimize and convince people to pay more. Right? Those days eventually do come with commercial companies. I mean, not to single out Amazon. I guess they all do that. And at this moment, if the commercial companies are running at a loss, they can't be running at a loss forever. It's an arms race. They're just trying to capture the market.
Right. So again, back to the question. So for somebody who cannot leave even a single bit of data from on-prem,
Yeah.
very secure, what is the LLM that you think you will recommend for somebody to run on-prem in a private network?
Oh, certainly
might not
start
know
with
the data.
Llama 2, like for general purpose situations, Llama 2, and Mistral. But see, it depends on your situation, right? If you're talking healthcare, there are the Gatatrons and so on and so forth, which are very good open source models. Bring them in-house. If you're doing text to speech, then you're talking Tortoise and so on and so forth. So you see, pick your problem, and you will be surprised how far open source models have come in each of these situations. So if you were to tell me the specific problem, perhaps I could tell you at this moment in that specific problem, which open source model is appropriate.
Right. I mean, let's say if there is a lot of unstructured data, there is a mix of a big data lake or even a data ocean kind of a thing sitting across on-prem, a very, very large one. And if you want to build like a basic chat GPT kind of a model with on-prem securely, so Llama 2 is the best, is it?
No, Llama 2 used to be the best. Now replace the Llama 2. It's almost a drop-in replacement. Replace it with either Mistral or with Zephyr. Those are the new things. They have just come out in the last month or so. You could use those. But I mean, if you think Llama 2, you're not far off. RAG is the way that you want to go. If you want to just chat to the knowledge base that you have and the data that you have internally, you're looking at RAG.
Okay.
Retrieval augmented generation, which is basically semantic search, a vector database or semantic search. Vector databases you can create in-house very, very easily. I mean, of course, people who don't have if they want the convenience of it or they're willing to pay the money, they could use Pinecone. There is no reason to. For example, in my last year, until last year, I was obviously leading the research in the leading corporate training company, Cornerstone on Demand. Their entire AI stack that I created, and for years we used in-house RAG.
Okay. Thank you.
Thank you, Partha. I'm gonna, before we go to Fernando, I'm just gonna read a very prominent person actually tweeting this on Twitter. And I am not making up these words, so it's important you hear me. After Elon Musk introduced Grok. So Grok appears to be the way more real-time, spicy, and fun compared to, I'm stressing this word, woke chat GPT. I wish he didn't say the word woke in there. So let's go to Fernando. I think you're about to ask that question regarding the the side of the AI ML bias and stuff like that. Please go ahead, Fernando.
Yeah, thank you. This is a great session. Thank you for that, for putting this together. Just to give you some context about my profile before asking, I used to architect VMware for big telcos, federal government, and cloud providers, right? So now I'm transitioning to architect VMware for financial services industry in US and Canada. So probably I'm offering myself to help with the AI side, right? So my question is about the following: how to prevent raising ethical questioning when training the models? For instance, preventing racial profiling when providing a great service for a small business or things like that. How we can, in general, avoid any ethics conflicts under AI when implementing AI?
Yes. Fernando, this is a very good question. And I must say, it's a minority of people who are very seriously looking into the ethics of AI. I'm very passionate about it. So I'll tell you this. First of all, you have to want to be ethical. And it's surprising how few people want to be. They just want to not do anything illegal, but if it is unethical, it still makes them profit. By all means, they'll go with it. The other aspect is, you have to be ethical. In the US, for example, they are the protected classes, like you said. The protected classes are race, gender, age, orientation, and so on, and disability and so forth. And if it is demonstrated that your system, AI system, is doing bias against them, then you are in violation of the law. Now, how do you prevent it? It cannot be prevented. It can be mitigated. People have tried to feed data to train the AI in such a way that data is unbiased. And then they say that, see, look, our data is, we have made sure, taken a lot of pains to show that the data is unbiased, and therefore our models are unbiased. That's not true, actually. Even if your data is unbiased, the model can easily become biased, because the data will have asymmetries, or it will have artifacts or artificial patterns in it that will mislead an AI to take shortcuts and get bias. So you need a system to check for biases in the inferences of the model. You need to put safeguards there. You need to put test suites to check for that. And in fact, that is one of the things we help companies do, to do that. And surprisingly, almost always we discover that people haven't taken care of even the basic things. They don't even have a test suite. They just say that, our data was pretty clean. We did not try to be biased, so it must not be biased. Of course, our inferences would be good. That's not how to think about it. It's a pretty nuanced thing. AI, the cleverness of AI models, the complex models, is that it will take every possible shortcut to make a good prediction. And sometimes those shortcuts introduce bias into the system. It's a fact of life. Now, European Union has an AI Act. US government is trying to bring one. Now, these rules are not perfect. And if you look at the technical community, they are all like, oh, this is so horrible and so forth. But at least it's a step in the right direction. There's an imperfect, but then those laws need to be brought in just to get people to seriously consider the ethical implications of AI. The second aspect is that because people are not looking into the ethics of AI carefully, we are in imminent danger. We are facing an existential danger to civilization itself. More and more, AI is getting into the hands of, or is commandeered by, very few extremely wealthy people, and it is leading to an unprecedented concentration of wealth throughout the world. And democracies are being toppled, and many things are happening. I hope I don't sound too woke after that comment on woke, but it's a fact. It is objectively seen as a fact today. Many of you remember the Cambridge Analytica, and the work that Cambridge Analytica did. They were implicated in the Brexit. They were implicated in toppling democracies in Latin America. They were even implicated in playing mischief with the US elections. And that was before these large language models came in. In fact, it was all done with the previous generation technology. So you can imagine what potential for harm there is, and why it is important to be worried about the ethics of all of this.
Perfect. Thank you. Appreciate it.
Thank you. Asif, there, just wanted to add a little bit to what Asif said. There is a tremendous discussion going on especially on Twitter, which I follow rigorously, about the White House executive order in terms of AI safety, and almost forcing the open models to be much more explainable. And you can't just roll out a model without basically explaining how the heck it works. And one of the debate that's been going on across the board is that all this data these models were trained on, especially from a transformers perspective, is the known human or animal knowledge. That's how they put it. If it is known human and animal knowledge, transformers are not going to basically do its own thing and make it existential threat. So that's the debate. There was a paper that just came out, as if I shared that with you today. You may not have had a chance to see that, but there's a lot of discussion on that. So being said, we'll go to Gopi for the next question.
Sorry, one second. If Gopi is trying to switch topics, I just wanted to check with Asif regarding the bias, right? Since we just finished that topic. So in bias, I've heard that these systems are actually better in bias than actually human beings, because we do have a lot of bias in a lot of things. So what is your opinion on that?
See, That's a very good question. And here is how my position is a nuanced situation. See, if you, first of all, large language models mirror civilization. They have learned from all that we have expressed. Human beings speak. They are a gregarious community and a very talkative one, right? So we write, we speak, we express, and all those expressions feed into the training of a large language model, right? So here's a reality. Human beings are on a spectrum. Today, for example, I mean, bias is always there. There is a statement I remember when I was in college. There was a person who was very passionate about social issues. And at some moment, I said, I'm a scientific person. I'm not biased. And she immediately said, Asif, everyone is biased. And it took me many years to realize that she was right. We all have biases that we know of and biases that we don't know of. One illustrative example that I would give is Aristotle, the great Greek philosopher. Even he had biases. He used to believe that men are brighter than women for, amongst other reasons, men have more teeth and a bigger brain. Obviously, he did not open Mrs. Aristotle's mouth and count the number of teeth there. Right? Otherwise, he would have discovered that's not true. And well, what about whales, which have even bigger brains than us? And so forth. So we all carry biases. Aristotle was considered a very enlightened philosopher. Today, when we looked at much of what he taught, we consider it to be pretty ignorant and biased. Right? There are sparkling gems of depth and wisdom there, but there's also a lot that is wrong. And so every successive generation finds that what we were had quite a bit of ignorance. So there is progress. Within human society itself, there are people who are deeply biased and they defend their biases. Right? The very fact that there are wars going on means there are segments of people who are fighting identity wars. People identify with one thing and they are biased against the other side. Right? It is going on in America. It's happening globally. The wars are everywhere. So bias is implicit. Are human beings better? Are LLMs less biased than human beings? That is a point that has been made for a very technical reason. What people have done is that once a LLM is trained on human knowledge, then the second thing that it goes through is some fine-tuning for a domain. And the third thing that it goes through is something called reinforcement learning with human feedback. So what you do is you take the LLM, a causal language model, to produce, let's say, 10 responses to the same input. And then you have a human being rank those responses. And you weed out the most toxic responses. You tell it, you give it a penalty that these responses are not good, they're terribly biased, and these are the better responses. But who is going to do the ranking? It is human beings. For example, in the case of ChatGPT, it was a whole army of Nigerians who were the human beings in the loop, rating the answers that this large language model was producing and saying which is better and not. So at the end of it, it is only as unbiased as perhaps the best effort of those people trying to be unbiased. And that is the limit of how unbiased a LLM can be. But is it truly unbiased? No.
Actually, a long topic. We could go on and on, but wonderful discussion. We have a couple more hands, and I am trying to respect everybody's time. We're almost at the top.
So yeah, we are on the top of the hour. So I will just take 30 seconds in the end to, so I'll kind of relinquish and let's have Krishnan go ahead of me, please.
Oh, thank you. So I have a couple of things in my mind. One on the biases, today there's just a comment. I saw the tweet from Vinod Khosla, but he was talking about, yesterday or today's tweet, about how the AI and, potentially can help us augment doctors and help us get more access to doctors. And in that sense, he was talking about biases that doctors and some of us or some of the spectrum in US across the world don't have access to the doctors, right? They're all biased in a certain way. So he was projecting that, even though AI may have some bias, it may be still better than what's happening in the reality. So that's a comment, coming from Vinod Khosla. So that's just a comment. On my second question, more about operational aspect. So a lot of this enterprise who wants to either use open LLM or fine-tune LLM or even self-model LLM, they are now thinking about how do we manage, operate, and monitor these and making sure things are working as expected. So what is the maturity of that LLM ops today? And where do we go from here in terms of the maturity of that?
So, Krishnan, to both the questions. First of all, I'll speak on the LLM maturity. Let me go to the Vinod Khosla comment. Yeah, that is a realization. See, in United States in particular, there is a vast, and throughout the world, there's a vast asymmetry between the number of people who are there and the ratio to doctors. Very few doctors, too many patients.
Yeah.
Especially in rural America, that's a problem. Secondly, especially in today, medical community, sad to say, are far behind when it comes to racial equality or gender equality or sexual orientation equality. It's a given fact, right? There is data after data that shows that. A Black woman, pregnant woman, gets a far worse treatment than a white pregnant woman. It's a known thing, right? So obviously, large language models are useful. The other thing is that it makes it more accessible. So instead of waiting for long time to get access to a physician or driving 200 miles to get to a physician, which is the reality in rural America today, isn't it far better that you can have access to an AI assistant which can act as a primary care, as a triage system that can figure out, are you in dire need of help, or is it just simple cold and flu and so on and so forth, and give you some help in the absence of a doctor. Those would be the big use cases of AI in medical. Now, the second part of your question was LLM maturity, the ML ops maturity. It is a fast evolving thing. Lots of startups are coming and doing it. For example, if you look at frameworks like Ray, Ray is created by the same guys who created Spark. Some of you in the technical field know that for large data computation, Spark is the leading distributed big data compute engine. Same guys are now creating the Ray compute framework, and in particular for AI, it's very AI centered. It is maturing very, very fast. We use it heavily with great success. It gives you monitoring and dashboarding and everything. It is not the only framework. There are many such frameworks coming out. Ray is leading the pack, but others are trying to catch up or having differentiators or having different things. Of course, cloud providers like Google, they give you their own frameworks, the whole Vertex AI and monitoring framework and so on and so forth. So those things are tooling up very rapidly. And I would say that they have achieved quite a bit of maturity in a very, very short time, I would say in this year itself.
Great, thank you.
All right, thank you, Gopi, for the platform. So I'll leave it to you for the final comment. Thank you, Asif. Wonderful discussion and appreciate the insights.
Yeah, I want to say thank you, Dr. Asif Kamar, for this lovely, engaging hour. And I also want to thank all the participants for fantastic questions that made this even more, it took it up a notch. It's one thing to come with a set of content to share, but to kind of be able to pivot it around the kind of questions you were asked. I think you did a fantastic job, and I really want to say a big thank you to that. And I think this is the kind of way we would like to see this forum thrive, right, Sushant? I'm kind of looking for any of you, your points, please come forward with, facilitating or offering some topics where we can kind of have these rich intellectual discussions, informal, Q&A, back and forth, that we all can learn something together and take away from. So that's just my, public service announcement. We'll be meeting in 2 weeks. That's, I think, November, 15th or something like that. So we don't have a speaker or a topic lined up for that. We'll be trying to do that between now and then and share in our chat group. So stay tuned for that. And if you're willing to, please reach out to me, or we'll put it on the chat and then we'll pick it up from there. But coming back to you, Madhu, thanks for preparing and anchoring this session. I really appreciate all the efforts, the energy, the thought that went behind this. And thanks for taking my feedback. And I think it's very much in alignment with what this group has been interested in talking, as you could see. So on that note, I think good night to you all. And I think once again, thank you.
Thanks a lot. Appreciate it.